The morning of July 14th, 1944, broke humid and overcast across the Norman countryside near St. Lo. Lieutenant General Omar Bradley stood beside a hedgerow, watching a light tank reverse 20 yards down a sunken lane. Around him clustered Major General Leonard Gero and several staff officers from the 2nd Armored Division. They had driven out from 1st Army headquarters to witness something that, according to Gero's breathless telephone call the previous evening, might change everything about the Bocage nightmare that was devouring American lives by the thousand. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The tank's engine growled as it pivoted, bringing its nose to bear on the ancient earthen wall before them. What made Bradley lean forward was not the tank itself, but the crude steel tusks welded to its bow. 4 prongs jutted forward like medieval lance tips, fashioned from what appeared to be scrap metal, rough cut and unpolished. The assembly looked absurdly simple, almost primitive, the sort of field modification that might earn a sergeant a reprimand for unauthorized alterations to army property. The tank accelerated, 10 miles per hour, straight at the hedgerow. What happened in the next 5 seconds would determine whether Operation Cobra, the massive breakout offensive scheduled to launch in 11 days, would succeed or become another grinding failure in the green hell that Normandy had become. The tusks hit the wall. Instead of the familiar sight of a Sherman's nose tilting skyward, exposing its paper-thin belly armor to any German with a Panzerfaust, the prongs bit deep. The tank's weight stayed level. Dirt erupted as centuries-old roots tore. The Sherman punched through the hedgerow like a fist through rotten canvas, emerging on the far side under a canopy of flying earth and vegetation, its guns level and ready, its vulnerable underside never exposed. Bradley would later write that the device was so absurdly simple it had baffled an entire army for more than 5 weeks. The man who had fashioned those steel tusks was not an engineer. He was not a West Point graduate. He was not a tank designer from Detroit's arsenal or a metallurgist from an ordnance laboratory. He was Sergeant Curtis Culin III, a 29-year-old reconnaissance tanker from Cranford, New Jersey, serving with the 102nd Cavalry Reconnaissance Squadron, the son of a Shenley Industries salesman. A man whose formal engineering education consisted of whatever practical mechanics he had absorbed working in civilian life before the war drafted him into a conflict where the rules of tank warfare, written for the plains of Poland and the deserts of North Africa, meant nothing in the ancient farmlands of France. The story of how one sergeant's rejected 5-second modification broke through the most intractable tactical problem of the Normandy campaign is not simply a tale of battlefield innovation. It is a story about the collision between doctrine and reality, about the price armies pay when they plan for the war they expect rather than the war they encounter, and about how the most profound solutions sometimes come not from those who designed the weapons, but from those who must use them to stay alive. To understand what Curtis Culin solved, you must first understand what the Bocage was, and why it had transformed the liberation of France into a meat grinder that threatened to stall the entire Allied campaign before it could properly begin. The word bocage comes from the Norman French, meaning wooded countryside. The definition, however, fails catastrophically to capture what American soldiers encountered when they pushed inland from the D-Day beaches in June of 1944. Bocage was not simply countryside with trees. It was a landscape that had evolved over 1,000 years into the most perfect defensive terrain in military history, created not by generals but by generations of Norman farmers who had no conception that their land management practices would one day shape the outcome of the 20th century's defining conflict. The Bocage stretched across northwestern France, covering much of the Cotentin Peninsula and extending south and east from the invasion beaches. It consisted of small, irregular fields, rarely more than 300 feet across, each surrounded by earthen embankments that averaged 4 feet high. These were not simple raised earth. The embankments, called talus by the French, had been built up over centuries as farmers cleared stones from their fields and piled them along property boundaries. Soil accumulated atop the stone foundations. Then came the hedges themselves, dense tangles of hawthorn, bramble, and small trees that grew from the embankments, adding another 6 to 12 feet of impenetrable vegetation. Root systems from centuries of growth had interlaced through the earthen berms, creating natural walls as solid as concrete and far more resistant to explosive demolition. The fields were connected by sunken lanes, roads that had been worn down below the surrounding land level by 1,000 years of wagon traffic and rainfall erosion. These lanes ran between hedgerows that towered overhead, creating natural trenches where visibility extended perhaps 50 feet in any direction. The entire landscape formed an interlocking network of tiny, enclosed battlefields, each field a separate fortress, each lane a potential kill zone. For defenders, the Bocage was paradise. German infantry could dig foxholes directly into the earthen embankments, creating positions that were invisible from ground level, protected from overhead artillery, and offering perfect firing positions into the next field where attackers would have to emerge. Machine gun teams could cover the narrow gaps between hedgerows with interlocking fields of fire. Mortar crews could register pre-plotted positions and drop rounds with devastating accuracy onto approaches they could not even see. Snipers found ideal hides in the dense vegetation atop the berms. Anti-tank teams could position their Panzerfaust rockets to cover the few openings where armor might attempt to pass, knowing that any tank using these gaps would be silhouetted and vulnerable. For attackers, the Bocage was hell. American infantry advancing across open fields were exposed to fire from enemy positions they could not see or suppress. The thick vegetation made artillery spotting nearly impossible. Forward observers could not see targets to direct fire. Air support, the massive advantage that American forces had enjoyed since gaining air supremacy, became largely useless because pilots could not identify targets hidden beneath the canopy of trees and hedgerows. Radio communication, already difficult in 1944, became sporadic and unreliable in the enclosed terrain. But the most devastating aspect of the Bocage was its effect on armor. The Sherman tank, America's primary armored vehicle, had been designed for mobile warfare across open terrain. In the Bocage, it could barely function. The narrow lanes between hedgerows were too constrained for maneuver. Attempting to drive down these lanes meant advancing in single file through obvious choke points that German anti-tank teams could cover with ease. A single disabled tank could block an entire column. Attempting to bypass these lanes by crossing the fields meant confronting the hedgerows themselves, and this was where the Sherman's design became its greatest liability. When a Sherman attempted to climb over a hedgerow embankment, the tank's weight distribution shifted dramatically. The bow rose as the tracks bit into the earthen wall. At the apex of the climb, as the tank crested the hedgerow, its entire vulnerable belly was exposed, tilted skyward. For perhaps 3 to 5 seconds, the Sherman's thickest armor, its frontal glacis plate, pointed uselessly at the sky while its belly, protected by less than an inch of armor in some places, faced the enemy. Any German soldier with a Panzerfaust, standing 50 yards away in the next field, had a perfect shot at the Sherman's weakest point, while the American tank's own gun pointed skyward, unable to engage. The tank crew was helpless. They could not reverse quickly enough. They could not return fire. They could only pray that no one was waiting on the far side. Many prayers went unanswered. Tank after tank was knocked out while bridging hedgerows, the armor's advantage completely negated by terrain that transformed every advance into an execution. Tank battalions that had expected to operate as mobile striking forces found themselves instead providing expensive, vulnerable, and largely ineffective artillery platforms, sitting behind hedgerows lobbing shells at an enemy they could not see. The casualties mounted with horrifying speed. In the 17 days following the capture of Cherbourg at the end of June, as Bradley's First Army attempted to fight south from Saint-Lô, American forces suffered approximately 40,000 casualties. Rifle companies lost nearly 60% of their enlisted men and over 68% of their officers. Some infantry divisions experienced replacement rates exceeding 150%, meaning that more men became casualties than the unit had started with. The 30th Infantry Division sustained 3,000 killed and wounded between July 7th and 20th. The 9th Infantry Division suffered 2,500 casualties between the 10th and 20th of July alone. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. This was not the war anyone had planned for. The massive pre-invasion training in England had focused on beach assaults and breakthrough operations across open country. Intelligence had identified the Bocage but had catastrophically underestimated its defensive value. Planners had assumed that once Allied forces broke through the Atlantic Wall and secured the beachhead, the advance inland would follow the pattern of mobile warfare that doctrine prescribed. They had prepared to fight panzer divisions in open country. Instead, they found themselves fighting individual German soldiers in terrain that multiplied defensive advantages 100-fold. The standard solutions were proving inadequate and unsustainable. Combat engineers used explosives to blast gaps through hedgerows, but the explosions advertised their intentions to every German within hearing distance, inviting immediate mortar and artillery fire. The army had bulldozer tanks, regular Shermans equipped with bulldozer blades, but these were conspicuously different from standard tanks and became priority targets for German anti-tank gunners, who understood that destroying the dozer tanks meant restoring the hedgerow obstacle. Each battalion had approximately 70 tanks, only 4 were dozers. They could not be everywhere, and their loss rates made them an expensive and scarce resource. Multiple units attempted to develop solutions. The 79th Infantry Division created a hedge cutter by early July. The 19th Corps demonstrated a set of prongs initially developed to create holes for explosives placement, which proved somewhat effective. Various units dubbed their inventions brush cutters and green dozers. None achieved what was needed: a simple, rapidly manufacturable device that could be fitted to any tank that would allow armor to punch through hedgerows without exposing vulnerable undersides, and that would restore the Sherman's mobility and firepower advantage. By mid-July, the situation had reached crisis levels. General Dwight Eisenhower and Bradley were under enormous pressure from Washington and from their British allies to show progress. The lodgement area in Normandy was becoming dangerously congested. Hundreds of thousands of men and thousands of tons of supplies were pouring into France through the Mulberry harbours and across the beaches, but the front lines had barely moved. The Germans were feeding reinforcements into the defensive positions. If the Americans could not break out soon, the entire Normandy operation risked becoming a grinding stalemate, reminiscent of the Western Front in 1917. Bradley was planning Operation Cobra, an unprecedented carpet bombing followed by an armoured breakthrough near Saint-Lô. The operation's success depended entirely on armour being able to exploit the gap created by aerial bombardment. If the tanks remained stalled by hedgerows, unable to maneuver and vulnerable every time they attempted to cross a field boundary, Cobra would fail. The Germans would seal any breach before exploitation forces could pour through. The Breakout would collapse into another costly, yard-by-yard slog through the Bocage. The solution was being welded together in a tank park behind the lines, fashioned by a sergeant who had never been asked to solve this problem, and whose innovation would be initially dismissed by the very engineers whose job was to create such solutions. Curtis Culin had been watching tanks for 6 weeks. As a reconnaissance trooper with the 102nd Cavalry Reconnaissance Squadron, his job was to probe ahead of main forces, to identify enemy positions and terrain obstacles. The Bocage had made reconnaissance almost suicidal. His light tanks could not simply scout and withdraw. Every advance into a new field meant crossing a hedgerow, and crossing meant exposure. He had watched friendly armour attempt the crossing and seen German Panzerfaust rounds strike exposed belly plates with devastating effect. He had participated in discussions among his unit's tankers about how to solve the problem, late-night conversations in bivouacs, where exhausted men tried to engineer solutions using whatever materials they could scrounge. One of these conversations involved a soldier whose name history has partially forgotten, though military historian Max Hastings identified him as Roberts, a Tennessee hillbilly, according to Hastings's account. During a discussion about overcoming the Bocage, Roberts suggested something that seemed absurdly simple. "Why don't we get some saw teeth and put them on the front of the tank and cut through these hedges?" The response was predictable. Laughter. The engineers had surely considered this. The ordnance experts knew the specifications of Sherman tanks. If a simple plough device would work, the army would have issued one. Roberts's idea was the sort of naive suggestion that someone without technical training might make, overlooking a dozen reasons why it could not work. The conversation moved on. But Curtis Culin did not laugh. Culin recognized something that the engineers, working from theory and specifications, had missed. He understood that the problem was not primarily one of force or power. The Sherman had plenty of engine power. The issue was geometry and weight distribution. When a tank climbed a hedgerow, its center of gravity shifted backward and upward, causing the bow to rise. What was needed was not more power, but a way to anchor the front of the tank low while the tracks drove it forward, allowing the tank to bore through the hedgerow rather than climb over it. Roberts's crude suggestion contained the kernel of a solution. Teeth on the front of the tank, not to saw, exactly, but to pin the bow down while providing cutting edges that could shear through roots and earth as the tank's weight and power pushed forward. Culin began sketching designs. He had access to scrap steel, specifically the German beach obstacles that had been cleared from the Normandy landing beaches and collected in salvage yards behind the lines. These were the Czech hedgehogs. Anti-tank obstacles consisting of 3 heavy steel beams welded together in a crossed pattern, each beam approximately 6 feet long. The steel was high quality, thick angle iron designed to withstand ship hulls and tank treads. It was exactly what Culin needed. Working in off-duty hours, Culin cut sections from the hedgehogs and began welding a prototype. The design evolved through trial and iteration. He settled on 4 prongs, each approximately 2 feet long, cut at sharp angles to create penetrating points. The prongs were welded to a crossbar, which could then be bolted or welded to the front glacis plate of a Sherman tank. The assembly weighed perhaps 200 pounds, a negligible addition to a 30-ton tank, the prongs angled slightly downward, designed to bite into the base of a hedgerow and hold the tank's bow down as it drove forward. The genius of Culin's design was its simplicity. It required no modification to the tank's engine, transmission, or suspension. It did not interfere with the main gun or bow machine gun. It used materials that were literally lying around in scrap yards. Any welder with basic skills could manufacture it. Any tank crew could have it fitted in a few hours. It solved the hedgerow problem not through sophisticated engineering, but through practical observation of what actually happened when tanks met hedgerows. But getting the design noticed required breaking chain of command protocols that could have resulted in disciplinary action. Culin was a sergeant. The proper procedure would have been to mention his idea to his platoon leader, who might mention it to the company commander, who might eventually pass it up to battalion staff, where it would likely die in paperwork or be dismissed as redundant with existing efforts. By the time it might reach someone with authority to test it, Operation Cobra would already have been launched and failed. Culin bypassed the normal channels. He requested a meeting with squadron officers, explaining that he had a potential solution to the hedgerow problem. To his credit, someone listened. Whether because the crisis was so severe that any idea deserved consideration, or because Culin presented his case with compelling evidence, he received permission to mount his prototype on a tank and demonstrate its effectiveness. The initial tests were conducted within his unit, probably in early July. A Sherman fitted with Culin's device approached a hedgerow at moderate speed. The prongs bit into the earthen embankment at its base. The tank's bow stayed level. The tracks drove the vehicle forward. The prongs, acting like ploughs, tore through the root systems and earth. Vegetation exploded upward as the tank punched through, emerging on the far side with its belly armor protected, its gun ready to engage, and its crew unscathed. The tank had gone through the hedgerow in approximately 5 seconds, faster than explosive breaching and without advertising its position. The test was repeated. Different hedgerows, different angles of approach. The device worked consistently. The squadron's officers recognized that they had something significant. Word began moving up the command chain, this time with official backing and photographic evidence of the device's effectiveness. By mid-July, the reports reached Major General Leonard Hedgerow, commanding the 5th Corps. Hedgerow was preparing his units for Operation Cobra, and understood exactly how critical the hedgerow problem was. He contacted Omar Bradley and suggested that the First Army commander should see this invention personally. Bradley, who had been wrestling with the Bocage nightmare for 6 weeks and who knew that Cobra's success depended entirely on armor mobility, agreed immediately. On the morning of July 14th, Bradley drove to the 2nd Armored Division's area to witness the demonstration. Culin's device had been fitted to both a light tank and a Sherman medium tank. Bradley watched as the light tank backed up, accelerated, and struck the hedgerow. The tusks bored into the wall. The tank stayed level and broke through under a canopy of flying dirt and vegetation. Then a Sherman duplicated the performance, the heavier tank punching through with even more authority. Bradley would later write in his memoir, A Soldier's Story, that he found Hedgerow and his staff clustered around a light tank to which a crossbar had been welded, with 4 tusk-like prongs protruding from it. He watched as the tank backed off and ran head-on toward a hedgerow at 10 miles per hour. Its tusks bored into the wall, pinned down the belly, and the tank broke through under a canopy of dirt. A Sherman similarly equipped duplicated the performance. It too crashed into the wall, but instead of bellying skyward, it pushed on through. Bradley recognized immediately what he was seeing. This was not just a useful modification. This was the solution that might make Operation Cobra possible. Without it, his armor would be stuck in the same Bocage nightmare that had plagued operations since June. With it, tanks could maneuver across the countryside, could pursue retreating Germans, could exploit breakthroughs. The device restored the Sherman tank to its intended role as a mobile weapon, rather than a vulnerable pillbox. The decision Bradley made in the next few minutes would determine the course of the Normandy campaign. He could have authorized limited production, perhaps equipping a few specialized units for testing in combat. He could have referred the device to ordnance committees for evaluation and refinement. He could have waited for engineers to improve the design before mass production. Any of these decisions would have been procedurally correct and operationally disastrous, because Operation Cobra was scheduled to launch in 11 days. Instead, Bradley made a command decision that reflected both the desperate tactical situation and his willingness to trust what his own eyes had shown him. He ordered immediate mass production. Every ordnance unit in First Army was to begin round-the-clock manufacturing of the hedgerow cutters. Every available welder was to be pressed into service. Scrap steel from German beach obstacles was to be collected and distributed to fabrication sites. The goal was to equip as many tanks as possible before Cobra's launch date, which was then scheduled for July 20th, but would ultimately be delayed by weather until the 25th. Lieutenant Colonel John Medaris, the ordnance officer, rushed back to headquarters and issued the production orders. By evening on July 14th, ordnance units across the First Army lodgement area were setting up welding stations. Trucks were dispatched to beach areas to collect Czech hedgehogs. By the morning of July 15th, fabrication was underway at multiple sites. The device, nicknamed the Rhino by troops who thought the tanks looked like charging rhinoceroses, began coming off improvised production lines. The production effort between July 15th and 25th was a remarkable example of battlefield improvisation at scale. There were no technical drawings beyond Culin's rough sketches. There were no standardized specifications. Each device was hand-fabricated by welders working from verbal descriptions and examples. The quality varied depending on the skill of the welder and the properties of the salvaged steel. Some devices were more robust than others. Some had slight variations in prong length or angle, but all of them worked well enough to solve the basic problem. By July 18th, when Cobra's launch was postponed due to weather, several hundred tanks had been fitted with the devices. The work continued. More welders were found. More steel was salvaged. By July 25th, when Cobra finally launched, approximately 500 tanks in First Army had been equipped with Culin cutters. This represented roughly 60% of the Sherman and Stuart tanks available for the operation. The 2nd Armored Division, which would spearhead the breakthrough, had equipped nearly 3/4 of its tanks with the device. Bradley made one more critical decision regarding the Rhino tanks. He ordered that they were not to be used until Cobra launched. No reconnaissance missions, no local attacks, no hedgerow crossings that might reveal to the Germans that American armor had acquired a new capability. The Rhino modification was to be kept secret until the moment it could have maximum operational and psychological impact. When Cobra's armor surged through the carpet-bombed breach in German lines, the Germans would suddenly face hundreds of tanks that could move freely across the Bocage, punching through hedgerows that had previously channeled and constrained American armor. The secrecy order reflected Bradley's understanding that the Rhino was not just a tactical tool, but a strategic surprise. The Germans had built their entire defensive strategy in Normandy around the assumption that American armor would remain road-bound or vulnerable when crossing hedgerows. Their anti-tank positions covered the obvious approach routes. Their counterattack plans assumed they could contain any breakthrough by forcing American tanks into predictable channels. The Rhino eliminated those assumptions. Operation Cobra launched on July 25, 1944, after multiple weather delays. The operation began with the largest tactical air bombardment of the war. Approximately 1,500 heavy bombers and 1,000 medium bombers and fighter bombers dropped nearly 4,000 tons of explosives on a narrow rectangle of German defensive positions northwest of St. Lo. The bombardment was intended to pulverize the Panzer Lehr Division and create a gap through which American armor could pour. The bombing was devastating but imperfect. Some bombs fell short, killing 111 American soldiers and wounding nearly 500, including Lieutenant General Leslie McNair, the highest-ranking American officer killed in the European theater. The German positions, while badly damaged, were not completely destroyed. Panzer Lehr lost perhaps half its combat power, but retained coherent units capable of fighting. The carpet bombing created massive cratering that actually impeded American armor movement in some areas. As the ground attack began, it was unclear whether the bombardment had achieved its objective. This was the moment when the Rhino tanks proved their value. As American armor pushed south from the bombing area, the lead elements encountered hedgerows that had survived the bombardment. In previous operations, this would have meant calling for engineers with explosives, or attempting vulnerable hedgerow crossings while exposed to any surviving German anti-tank weapons. Instead, the Rhino-equipped Shermans simply accelerated and smashed through. The effect was immediate and multifaceted. Tactically, American armor could now maneuver across the countryside rather than being confined to roads and lanes. Tanks could pursue retreating Germans across fields. They could flank German defensive positions by approaching from unexpected directions. They could avoid obvious ambush sites by cutting new routes through the Bocage. The mobility that Sherman tanks had been designed for, but had been denied by the terrain, was suddenly restored. Psychologically, the impact on both sides was profound. American tank crews, who had spent weeks viewing every hedgerow as a potential death trap, found that the obstacles had become mere inconveniences. The constant anxiety of exposure while cresting hedgerows was replaced by aggressive confidence. Tank commanders began taking initiative, seeking opportunities to exploit rather than focusing primarily on survival. The difference in morale was measurable in the increased pace of advance and willingness to pursue contact. For the Germans, the Rhino tanks created profound disorientation. The defensive doctrine that had worked so effectively for 6 weeks suddenly failed. American tanks appeared where they should not have been able to go. Carefully prepared anti-tank positions, covering likely approach routes, found themselves bypassed, as Shermans cut new paths through the hedgerows. The Bocage, which had been the Germans' greatest ally, betrayed them. Units that had expected to conduct a controlled, delaying action found themselves overrun or encircled by armor that moved faster than doctrine suggested was possible. The breakthrough achieved in the first 72 hours of Operation Cobra exceeded even Bradley's optimistic projections. By July 27th, American armor had advanced several miles and was beginning to reach more open terrain south of the densest Bocage. By July 28th, the German defensive line had effectively collapsed. Major General J. Lawton Collins's 7th Corps had torn a gaping hole in German defences, and exploitation forces were pouring through. On August 1st, Lieutenant General George Patton's Third Army became operational, flooding through the gap that Cobra had created. The Culin Hedgerow cutter had not won the Battle of Normandy by itself. The massive aerial bombardment, the superiority in numbers and logistics, the courage of infantry and tankers, the weight of multiple simultaneous operations all contributed to the eventual breakout. But the Rhino device solved a specific, critical problem at exactly the moment when that solution was needed most. It transformed Operation Cobra from a potentially stalled offensive into the decisive breakthrough that led to the liberation of France. The immediate tactical success of the Rhino tanks in Operation Cobra led to questions that military historians and Bradley himself would wrestle with for years afterward. Why had it taken so long to develop such a simple solution? Why had Army engineers, with their technical training and resources, failed to produce what a sergeant created in his off hours using scrap metal? The answers reveal uncomfortable truths about institutional thinking, the gap between doctrine and battlefield reality, and the ways that hierarchical organizations can become blind to solutions that originate outside official channels. The Army's ordnance and engineering branches had not been idle during the Bocage fighting. Multiple experimental devices had been developed and tested. Some units created elaborate assemblies using salvaged railroad rails. Others tried variations on bulldozer blades. Engineers experimented with explosive charges shaped to blast horizontal gaps through hedgerows. Tank crews jury-rigged various arrangements of steel plates and cutting edges. None of these solutions achieved what was needed because they approached the problem from the wrong angle. The engineers were trying to cut or blast through hedgerows as if they were vertical walls of vegetation. They focused on the above-ground portion of the obstacle, the trees and bushes and tangled growth. Culin understood that the real obstacle was underground, the ancient root systems and compacted earth of the embankments themselves. His prongs attacked the base of the hedgerow, where centuries of accumulated soil and stone created the structural foundation. By tearing through this foundation while keeping the tank level, the Rhino allowed the Sherman's weight and power to do what explosives and cutting blades could not. The difference between Cullin's approach and the official engineering solutions reflected a fundamental divide between theoretical problem-solving and practical experience. Engineers worked from specifications and calculations, analyzing force requirements and structural properties. Culin worked from observation, watching what actually happened when tanks met hedgerows, and recognizing that the problem was not insufficient force, but incorrect application of that force. He had seen dozens of tanks belly skyward. He understood intuitively that keeping the bow anchored low would prevent the exposure that made hedgerow crossings lethal. There was also a cultural factor. Military organizations, particularly in wartime, develop institutional momentum that can be difficult to redirect. Once procedures are established and chains of command are defined, solutions are expected to flow downward from experts to implementers. A sergeant suggesting that he had solved a problem that had stumped division-level engineers violated the implicit hierarchy of expertise. That Cullin's chain of command listened to him, and that Hedgerow and Bradley acted on his demonstration rather than referring it to committees for evaluation, represented unusual flexibility in an organization not known for flexibility. The aftermath of Cobra demonstrated the Rhino's value across multiple operations. As American forces broke out of Normandy and began racing across France in August 1944, the hedgerow terrain persisted in many areas. Rhino-equipped tanks continued to provide mobility advantages, allowing armoured columns to move cross-country when roads were blocked or cratered. The devices remained fitted to many tanks even after leaving Normandy, becoming a distinctive visual characteristic of American armour that had fought in the Bocage. The British also recognised the value of hedgerow cutting devices. The Royal Electrical and Mechanical Engineers developed their own version, which they called prongs. Initial production used captured German beach obstacles, but subsequent manufacturing occurred in the United Kingdom. By August 1944, 600 Mark I prongs had been delivered for Sherman tanks. An additional 1,000 Mark II prongs were produced for Sherman's and Munton tank destroyers, and 500 Mark III prongs were manufactured for Cromwell tanks. The Churchill tanks were not initially considered to need the modification due to their different weight distribution and climbing ability, but some were equipped anyway. For Curtis Culin personally, the recognition was both immediate and incomplete. On July 14th, after Bradley witnessed the demonstration and ordered mass production, Cullin's role was officially acknowledged. He was awarded the Legion of Merit, a prestigious decoration given for exceptionally meritorious conduct in the performance of outstanding services. The citation recognized his invention as having significantly contributed to the success of Operation Cobra and the broader Normandy campaign. His name appeared in after-action reports and in Bradley's communications with higher headquarters. But fame, even military fame, is fleeting and often superficial. While Culin received his medal and the acknowledgement of senior officers, the public narrative of the Hedgerow cutter quickly became simplified. Newspaper accounts mentioned Sergeant Culin's invention without capturing the full context of institutional resistance overcome or the collaborative nature of battlefield innovation. The story became a feel-good tale of American ingenuity rather than a more complex examination of how organizations learn or fail to learn. Moreover, Culin himself, being as Bradley described him an honest man, attempted to give credit to Roberts, the soldier whose offhand suggestion had sparked the idea, but Roberts's name was forgotten in the publicity surrounding the invention. Military historian Max Hastings, writing decades later, had to reconstruct Roberts's role from fragmentary accounts. The historical record simplified the story to Culin as sole inventor, erasing the collaborative conversation that had generated the breakthrough. This pattern of simplification, turning complex innovations into individual genius narratives, would be repeated in how the Hedgerow cutter entered popular memory. Culin's war did not end with his invention's success. He continued serving with the 102nd Cavalry Reconnaissance Squadron as Allied forces pushed across France and into Germany. By September 1944, American forces had liberated Paris and were approaching the German border. The nature of the fighting changed from breakthrough operations to sustained pursuit and then to grinding combat against increasingly desperate German resistance in their homeland. In November 1944, Cullin's unit was fighting in the Hurtgen Forest, a densely wooded area along the German-Belgian border that became the scene of some of the war's bloodiest and most futile battles. The Hurtgen Forest fighting shared some characteristics with the Bocage: limited visibility, short engagement ranges, terrain that negated American advantages in armor and air support. But the Hurtgen was worse in many ways. The forest was darker, the positions more fortified, the weather more brutal, and the German defenders were fighting for their homeland with the desperation of men who knew defeat was inevitable but still refused to yield. On an unrecorded date in November 1944, Sergeant Curtis Culin stepped on a German landmine. The explosion destroyed his left leg. He was evacuated from the front line, transported to field hospitals, and eventually sent to medical facilities in England and then the United States for treatment and rehabilitation. His combat service was over. He was 29 years old. He had invented a device that helped win the Battle of Normandy, received the Legion of Merit, and lost his leg in a forest that would consume thousands of American lives before finally being taken in February 1945. Culin recovered from his injury and returned to civilian life in 1945. He married Bernice Enright that year in his hometown of Cranford, New Jersey. He returned to work, taking a position with Schenley Industries, the same company where his father had been employed. The couple lived in New York City, far from the hedgerows of Normandy and the forests of Germany. Culin's wartime service became a part of his past, acknowledged in family circles and among fellow veterans, but not something that defined his post-war identity. His marriage to Bernice ended in divorce in the early 1950s. The reasons remain private, but the strain of war injuries, both physical and psychological, destroyed countless marriages among veterans of that generation. Culin continued working as a salesman, a profession far removed from the welding and tank warfare that had briefly made him significant to military history. He lived quietly in Greenwich Village, Manhattan, maintaining connections with his family in New Jersey, but largely staying out of public view. Curtis Grubb Culin III died on November 20th, 1963, in Greenwich Village. He was 48 years old. His death received little public notice, The newspapers that mentioned it identified him simply as a World War II veteran who had worked in the wartime shipyards, apparently confusing his service or conflating different aspects of his life. The specific details of his hedgerow cutter invention were not mentioned in his obituary. He was buried with military honours, his Legion of Merit among his decorations, but the general public had largely forgotten what he had contributed to the war's outcome. The irony was profound. Culin had solved a problem that threatened to derail the liberation of Western Europe. His invention had been used by hundreds of tanks and had directly contributed to the success of Operation Cobra, which military historians regard as one of the decisive operations of the war in Europe. General Eisenhower himself, in one of his final addresses as President of the United States on January 10, 1961, had specifically mentioned Culin's invention before the American Society of Mechanical Engineers, describing how a little sergeant named Culin had an idea about fastening great big steel knives to the front of tanks, and how that idea had worked its way up the chain of command, until General Bradley did something about it very quickly. Yet Culin died in relative obscurity, his contribution known to military historians, and recorded in official histories but not celebrated in popular memory the way some other wartime innovations were. The hedgerow cutter became famous. Culin remained obscure. The device was called the rhino or the Culin cutter in official documents, but in popular accounts it often appeared simply as an example of American battlefield ingenuity without specific attribution. This pattern reflects a broader truth about innovation in warfare. The individuals who create tactical solutions are rarely those who receive lasting recognition. Weapons systems designed by famous corporations or named scientists become iconic. The Garand rifle, the Sherman tank, the Norden bomb sight all carry their designers' names or corporate identities into historical memory. But the field modifications, the improvised solutions created by soldiers facing immediate survival challenges, tend to be attributed to collective American ingenuity rather than to specific innovators. Culin's hedgerow cutter joined a long list of battlefield innovations whose creators remained largely unknown except to specialists. The legacy of Culin's invention, however, extended far beyond his personal recognition. The hedgerow cutter established principles that would influence military procurement and doctrine for decades. The experience of the Bocage demonstrated that even the most carefully designed weapon systems might prove inadequate when confronted with unexpected terrain or tactical situations. The Army learned, or should have learned, that frontline soldiers often possess practical insights that staff officers and engineers lack. The willingness to listen to sergeants with field improvised solutions and to implement those solutions rapidly, even when they contradicted official procedures, became an important lesson for future conflicts. The speed of the Rhino's development and deployment, from demonstration to mass production in 11 days, stood in stark contrast to the typical pace of military procurement. In peacetime, such a modification would have required months of testing, evaluation, and approval through multiple bureaucratic layers. Combat necessity compressed that timeline to less than 2 weeks, proving that when institutional barriers are removed, militaries can adapt with remarkable speed. This lesson would be partially forgotten and painfully relearned in subsequent conflicts, from Vietnam to Iraq, where soldiers again found themselves needing equipment and modifications that official channels were slow to provide. The Bocage fighting and the hedgerow cutter also influenced post-war tank design. The experience demonstrated that armor needed to be able to handle a wider variety of terrain than designers had anticipated. Future tank development incorporated lessons about weight distribution, bow design, and the need for auxiliary equipment mounting points. While no subsequent American tank was designed specifically for hedgerow fighting, the recognition that tanks might encounter unexpected obstacles influenced design philosophies around versatility and modification capability. More broadly, the Normandy campaign established intellectual frameworks about combined arms operations, the importance of infantry-tank cooperation, and the limitations of armor in restrictive terrain. Military academies would study the Bocage battles for decades, using them to teach officers about adaptation, the relationship between terrain and tactics, and the dangers of over-reliance on doctrinal solutions. The hedgerow cutter became a case study in how tactical problems require tactical solutions that might not come from expected sources. The physical artifacts of Culin's invention are scattered and rare. Most of the rhino devices were removed from tanks after the breakout from Normandy, when the dense bocage gave way to more open country. The steel was recycled or discarded. A few examples survived, preserved by museums or collectors who recognized their historical significance. The National Museum of the United States Army displays a Sherman tank equipped with a hedgerow cutter, one of the few remaining examples of the device that helped break the Bocage stalemate. The museum's interpretation explains Culin's role and the device's impact, ensuring that visitors understand the human story behind the rusted steel prongs. In Cranford, New Jersey, Culin's hometown, a memorial plaque was erected outside the municipal building. The inscription identifies Curtis Culin III as a World War II soldier who invented the hedgerow cutter that helped Allied forces liberate France. The memorial is modest, a bronze plaque on a boulder, but it represents official recognition by his community of his contribution. Local historians maintain records of his service. Veterans organizations acknowledge his innovation during commemorative events. The recognition is local and limited, but it ensures that Culin's name is not completely forgotten. The broader narrative of the Normandy campaign has increasingly recognized the hedgerow cutter's importance. Popular histories of D-Day and its aftermath typically include at least a mention of Culin and his invention. Some accounts provide extensive detail about the Bocage fighting and the desperation that led to the rhino's development. Documentary films about Operation Cobra almost always include footage or dramatizations of Sherman tanks smashing through hedgerows, acknowledging the device that made such movement possible. The story has become a standard element of how World War II is taught and remembered, even if Culin himself remains less famous than his invention. What makes Culin's story particularly resonant is its demonstration of how solutions emerge from the interaction between institutional resources and individual initiative. Culin could not have developed the hedgerow cutter without the broader military context that provided him with tanks, welding equipment, scrap steel, and a desperate tactical need. But the institutional army, despite its vast resources and technical expertise, had failed to produce the solution that a sergeant created in off-duty hours. The innovation required both the individual insight and the institutional willingness to recognize and implement that insight rapidly. This combination, individual creativity plus institutional flexibility, proved decisive not just for the hedgerow cutter, but for the Allied victory in Normandy more generally. The campaign was filled with improvisations, from naval officers adapting fire support procedures to infantry developing new small unit tactics for Bocage fighting. The armies that learned fastest, that incorporated frontline experience into doctrine most rapidly, gained significant advantages over those that remained rigid. The German army, despite its tactical sophistication and experienced veterans, was defeated in part because it could not adapt as quickly as the Allies could improvise. The story also reveals the particular character of American military culture in World War II, a culture that combined formal hierarchy with surprising pragmatism. Bradley, despite being a lieutenant general commanding hundreds of thousands of men, was willing to personally observe a sergeant's invention and to immediately order mass production based on what he saw. There was paperwork, there were procedures, but there was also a recognition that combat necessity trumped bureaucratic caution. This combination of formal structure and practical flexibility characterized the American military at its best, allowing it to leverage both organizational resources and individual initiative. In the decades following the war, as historians examined the Normandy campaign in increasing detail, the hedgerow cutter's role grew in their assessments. Early histories, written in the immediate aftermath of the war, often glossed over the Bocage fighting as a difficult but ultimately overcome obstacle. Later scholarship, with access to more detailed unit records and veteran interviews, recognized how close the Normandy campaign came to stalling completely in the hedgerows. The July offensive that preceded Cobra had cost 40,000 American casualties for minimal territorial gains. Without a breakthrough, the lodgement area risked becoming a death trap, congested with troops and supplies but unable to expand. The Hedgerow cutter, by enabling the mobility that Cobra required, helped avert a potential strategic disaster. This reassessment elevated Culin's invention from a useful tactical modification to a potentially war-changing innovation. While it would be excessive to claim that the Rhino won World War II, it is fair to say that it significantly contributed to winning the Battle of Normandy, and that victory was essential to the Allied triumph in Western Europe. The causal chain is clear. Without mobility through the Bocage, Cobra likely fails or achieves only limited success. Without Cobra's breakthrough, the Normandy campaign continues as a grinding attrition battle that could last weeks or months longer. A delayed breakout from Normandy might allow the Germans time to establish stronger defensive positions or might give them opportunity for more effective counterattacks. The invasion might still ultimately succeed, given Allied superiority in resources, but the cost would be measurably higher and the timeline significantly extended. So when we consider Curtis Culin's contribution, we are not simply acknowledging a clever technical solution. We are recognizing that battlefield innovation at a critical moment, implemented by a sergeant and authorized by a general willing to trust what he saw, materially affected the outcome of the war. The 5 seconds it took a Rhino-equipped Sherman to punch through a hedgerow represented the difference between stalemate and breakthrough, between tactical paralysis and operational mobility, between thousands more casualties and a relatively rapid liberation. The human element in this story deserves emphasis. Culin was not a genius inventor or a professional engineer. He was a reconnaissance sergeant doing his job, observing problems, and trying to solve them because unsolved problems got people killed. His innovation came from the same impulse that drove thousands of other soldiers to improvise, adapt, and overcome. What distinguished his solution was not that he thought creatively every soldier did that, but that his creative thinking produced a result that was simple enough to mass-produce, effective enough to matter operationally, and lucky enough to reach commanders who could implement it at scale. The willingness of Roberts to voice his seemingly naive suggestion, the willingness of Culin to take that suggestion seriously, the willingness of squadron officers to let Culin demonstrate his prototype, the willingness of Hedgerow to bring it to Bradley's attention, and the willingness of Bradley to order immediate mass production. This chain of institutional flexibility was as important as the technical innovation itself. Remove any link in that chain, and the Hedgerow cutter either never gets developed or arrives too late to affect Operation Cobra. This is perhaps the most important legacy of Culin's story for modern military organizations. Technical excellence and engineering sophistication matter, but so does the cultural willingness to listen to ideas from unexpected sources and to implement them with urgency when circumstances demand. The sergeant in the field may see solutions that the colonel at headquarters cannot, not because the sergeant is smarter, but because the sergeant experiences the problem directly. Creating institutional channels that allow those insights to flow upward quickly and creating command cultures that act on those insights decisively can produce advantages as significant as any weapons system. As we look back across 8 decades at that morning of July 14, 1944, when Omar Bradley watched a Sherman with crude steel tusks smash through a Norman hedgerow, we see a moment that crystallizes what made Allied victory possible. Not just material superiority, though that mattered, not just bravery, though soldiers on all sides demonstrated that, but the combination of pragmatic flexibility, rapid adaptation, and willingness to implement solutions from unexpected sources that characterized the Allied, and particularly the American, approach to war. Curtis Culin returned to civilian life, worked as a salesman, divorced, lived quietly, and died young. His invention outlasted him in memory and impact. Every Sherman tank preserved in museums, every historical documentary about Normandy, every academic study of Operation Cobra carries forward the legacy of the 5-second breakthrough that a sergeant from New Jersey made possible. The hedgerows of Normandy are still there, gentler now and carefully maintained, but recognizable to anyone who understands what they once meant to the soldiers who faced them. And somewhere in salvage yards or museums or private collections, a few pieces of steel cut from German beach obstacles and welded into prongs remind us that sometimes the greatest innovations come not from laboratories or design bureaus, but from someone who watched a problem kill his comrades, refused to accept that no solution existed. The Bocage did not defeat the American army. Curtis Culin ensured that it would not. 4 steel prongs, 200 pounds of scrap metal, 5 seconds of breakthrough. That was the margin between stalemate and liberation, between the Normandy campaign dragging into autumn and the liberation of Paris by late August. History turned on small moments and simple solutions. This was one of them. Watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.